Alex props a ladder against a wall. The ladder makes an angle of 23 degrees from the ground. If the ladder is 10 feet long, what is the expression for finding the distance of the foot of the ladder is from the wall? All right, so we're going to draw our figure here. Let's pretend this is our scratch paper. For problems like this, I always recommend you draw a picture. Literally 100% of the time. If you're dealing with shapes, there's no reason you shouldn't be visualizing them on your page. Okay, so what do we have here? We have the ground, we have a wall, and we have a ladder. What specific information are we given in the question? Well, we know the ladder makes an angle of 23 degrees from the ground. Okay, this is the ground, this is the ladder, so we know this angle here is 23 degrees. What else do we know? If the ladder is 10 feet long, what is the expression for finding the distance the foot of the ladder is from the wall? Okay, the ladder is 10 feet long. This here is our ladder. We can label that side length as 10. And what are we trying to find? We're trying to find the distance from the foot of the ladder to the wall. This is the foot of the ladder, this is the wall, so we want to find this side length here. We're solving for x. A lot of the work of these problems is just figuring out what you know and what you want to know. So this step is really very key. At this point, all we have to do now is figure out which of our trig functions we can use to find this side length down here. So obviously, the only angle measure we're given is this angle here, 23 degrees. So that's the angle we're going to use for our trig function. So now, related to this 23 angle right here, what values are we working with? We have this x down here, and we have this 10 up here. And as we've been saying this whole time, the hypotenuse, right, is the largest side opposite the largest angle. Here we have 10 being our hypotenuse, so we know we want one of the trig values that involves the hypotenuse. And then which one do we have from the angle? Do we have opposite over hypotenuse or adjacent over hypotenuse? Well, we have 10 on one side, we have x on the other side, so this side length is adjacent to the angle. So we are working with the adjacent side and the hypotenuse. So then we go SOHCAHTOA, which one involves adjacent and hypotenuse. CAH, C-A-H, cosine is adjacent over hypotenuse. So now we can use that to find the length of this side. So if we say cosine of x, or of, well, not x here, this is our side length, but cosine of our angle, 23 degrees, equals adjacent x over hypotenuse, 10. Now it's just a matter of simple algebra. We want to solve for x, so we'll multiply both sides by 10, giving us 10 cosine of 23 degrees equals x. Now, depending on the setup for the problem, you could use your calculator to punch this out, type 10 times cosine 23, and then hit enter, and it would give you an actual value for this. Or if you're in the multiple choice section of the test, which is actually where I pulled this from, you'll be given a few options, and you might be able to leave it just like this. That's how the question was set up. It gives you 5 different answers to choose from. In this case, it was 10 times the tangent of 23 degrees, 10 times the sine of 23 degrees, 10 times the cosine of 23 degrees, cosine of 10 over 23, or sine of 10 over 23. And as we see, we ended up with 10 times the cosine of 23 degrees. That was option C. So again, this is sort of the basics of trigonometry. Whenever we're dealing with this, you've got to keep in mind SOHCAHTOA, know what that means, and be able to figure out, all right, what information have I given, what do I want to find, and how can I use these 3 relationships to get that answer. There are a few other concepts within trigonometry that are important to keep in mind. There are 3 other trig functions that are the inverse of each of these. We have sine, cosine, and tangent. We also have cosecant, the opposite of sine, secant, the opposite of cosine, and cotangent, the opposite of tangent. There's also the law of sines, the law of cosines. There are a few other ideas that we can discuss in future lessons, but for now, these are the fundamental basics of how to use trigonometry on the SAT math section. Thank you. I hope you enjoyed the lesson.